Rectilinear motion, particle on track, part 4. In the previous video we have discussed about that if there are 3 time intervals, then how we will deal with this. So how we will deal with this, we have just know about the distances between the 3 points. Between the 4 points there are 3 distances are there and 3 time intervals are taken there. Not only that, we have no information about the velocities. We have no the time intervals and the distance. Now we try to face a different scenario and we try to prove a different identity. Let us see. So let us consider a particle is somewhere here, and at t equal to 0 it is at the point capital P, say. Then it is moved to capital Q point, and in reaching capital 2 it takes the time t1 and its velocity, average velocity in reaching, that is u1. Okay, is u1, let us take, and it is initially starts from 0, and when it reach here at t equal to t1, at the time the velocity is at the point Q is not known to me, but when it reaches the point R, the time is now t2, and in between t1 and t2 the time interval is t2, so it will be t2 plus t1, and the average velocity, that is with the velocity it is continued its motion, that is u2. And when it is reaches from R to another point, the final point or the finishing point S, the time taken by it in reaching there is t3, and the average velocity is here u3. The total time in reaching P2S is t1 plus t2 plus t3, and from this we have to prove that u2 minus u1, u3 minus u2 equal to t1 plus t2, t2 plus t3. Okay, this thing we have to prove. So we have the information about the average velocities. So let us consider here the velocity is 0. So let us consider velocity. Here we can consider it is v, here it is v prime, here it is v double prime. So what is u1 here? u1 equal to basically 0 plus v divided by 2. What is u2 here? u2 is v plus v prime, v plus v prime divided by 2. What is u3? u3 is here v prime plus v double prime divided by 2. So this is the thing. Now if I want to represent this, that is u2 minus of u1 divided by u3 minus of u2. So what it will be? So u2 is this v plus v prime divided by 2. What is e1? e1 is this only v by 2. And u3 is here v prime plus v double prime divided by 2. What is u2? u2 is v plus v prime divided by 2. So if I just subtract this thing, it will be v prime divided by 2 above, and In down, this v prime and this v prime cancels out, though this will be v double prime minus of v divided by 2. So these 2 and these 2 will be cancelled out, so it will be v prime v double prime minus of v. So almost this is the thing. So if I want to write down this thing here, then what it basically represents the v prime. So what is v prime? It is v prime. So v prime, if I consider it is 0, it will be 0 plus, if the average acceleration all over the path is a, if I consider, then in reaching this point the time is t2 plus t1. Okay, now if I talking about the v double prime, so it is v double prime, initial velocity is 0 plus a, it is t1 plus t2 plus t3. What is v? V is 0. Here 0 I am representing, that is the initial velocity here. So 0 plus a t1. So if I do the cancellation procedure, it will be a into t2 plus t1, and this thing will be t1 plus t2 plus t3 minus t1. These will be t2 plus t3. So if this a cancels out, so from here u2 minus of u1, u3 minus of u2 equal to t1 plus t2 divided by t2 plus t3. So this is the thing. This is another popular identity that is several times it comes to prove, but concerning about one thing, that here the u1, u2 and u3 are not the initial velocities, these are the average velocities. Till now we have considered the 2 time intervals, after the 3 time intervals. Now if I consider n number of time intervals, just like here if we have started from here, that is, it is the first one, and here the velocity is 0, that is the displacement is 0, we can consider, or the velocity is 0, u equal to 0 here, and after that we just consider this is the total distance and it is extended up to a long interval, so I just use the dotted sign, and let us take the total distance is s, and we just separate it into very small time interval, just like from here to here it is s by n, from here to here it is s by n, from here to here it is s by n, just like small n time intervals. And when it reach here, the velocities are in the time intervals are vn. So this way it is continuous up to n terms. So, and the acceleration, I want to say the acceleration that is here considered, it have a particular thing, particular way it is increasing, and that increase, I want to say the acceleration when it is at the first time interval, it is a. In the second, it is a by n, just added with a by n is added with this. After that again a plus a by n is added with this. Okay, after that again a by n will be, if I take another time interval, again a by n is added with this. So this way the acceleration is increasing, and after that it will just make it the effect on the particle's velocity. So how it will be, if I write down the equations, that is v1 square equal to 0 square plus 2 into a into s by n. I think you have understood this thing I have written from in going from here to here. Then if I write down this thing, that is v2 square equal to v1 square plus 2 into a plus a by n, and from here to here the distance covered is obviously s by n. Now in going from here to here, it is v3 square, it is v2 square plus of 2 into a plus 2a by n into s by n. Okay, this way if I write down after the v4, then it will be, then if I write then after that v4 equal to v3 square plus 2 into a plus 3a by n is by n. So this is the thing. So if I just substitute this v1 square from this expression here, then it will be 2a, it will be 2a into s by n plus 2a from here 1 plus 1 by n into s by n, s by n, sorry, not 2, s by n. After that from here if I write here, so it will be 2a s by n plus this, so it will be 2a s by n plus 2a into 1 plus 1 by n into s by n. Now if I add this thing here, then it will be 2a 1 plus 2 by n into s by n. So this way it will increase. So if we are continuously doing this, after that, after some time we will get this vn square. So what is this vn square? So obviously it will be the sum of v1 square plus v2 square, and after that it is just added up. Okay, just like v2 square is the sum of v1 square, and v2 square, in v2 square sum here, this v1 square is hide, and here also in v3 square sum is v2 square, and in v2 square v1 square is somehow is hidden. So if I write down this thing, then we have to just add it up to n terms. So if I just write down this thing, then v1 square equal to 2a is by n, v2 square equal to 2a is by n plus 2a into 1 plus 1 by n into s by n. Now if I add this thing, then it will be 2a s by n into the previous one, that is 2a into 1 plus 1 by n into s by n plus 2a into 1 plus 2 by n into s by n, and these will be obviously extended up to n terms. This thing obviously extended up to n terms. So basically it becomes a arithmetic progression or series, I want to say. So if I take 2a is by n as a common, so I need not to write down it again and again. So you can see from here it is 1 plus 1 by n plus 1 plus 2 by n. These terms are repeated continuously, so these up to n terms. So here if I just take this term here, so it will be 2a is by n. So these ones are continuous up to n times. So I can say this thing, this 1 plus 1 plus 1, this thing continue up to n terms, and this 1 by n term that is here, that is 1 by n term that is here, we can say it is 1, after that 2, after that 3, this thing is continued up to n minus 1 terms. Now from here we have a very basic informations about the series from the mathematics. If we add 1 up to n terms, then it will be 2a s by n, 2a s by n, 1 are added up to n terms, so it will be simply n. And here is 1 by n. 1 plus 2 plus 3 dot dot n minus 1 terms. So what is the formula of that? You know, the formula is the number of terms divided by 2. The first term is here 1, and the last term is here n minus 1. Okay, the number of terms divided by 2, the first term plus last term. The first term is here 1 and the last term is here n minus 1. So if I calculate this thing, then obviously this 1 and minus 1 will be cancels out. So it will be 2a is by n, it is n, plus 1 by n into n minus 1 into n divided by 2. So this n and this n cancels out. Okay, this n and this n cancels out. After that, if we do the calculation, so this is the thing. So after that it will be 2a is by n, it is 2n plus n minus 1 divided by 2. So it will be 2a is by n, 3n minus 1 divided by 2. 2 and 2 cancels out, and obviously that we am calculating, that is Vn square. So Vn square equal to, we can say it is a s by n, 3n minus 1 equal to a s into 3 minus of 1 by n. So this Vn equal to root over of a s into 3 minus of 1 by n. So this is also a teacher's favorite question. So you are the student, so you have to remember this type of series and this type of proofs also. Let us take a real value problems. Let us take a real value problem. That the problem is something like that. Here is two stations A and B, and the distance between them I can take, that is 2 kilometers. Okay, so the time taken by the train in reaching from A to B is 4 minutes. Okay, so the train is accelerated by an acceleration a1. Okay, the first distance, I don't know what is the distance, I can say this is d1, and the rest of the part it is moving with an retardation a2. I don't know what is the value of d1 and what is the value of d2. What I have to prove? I have to prove that 1 by a1 plus 1 by a2 equal to 4. So I can identify this thing as the first interval. This is the first event and second event. Now if I write down for the first event, that is v equal to 0, v equal to 0 plus acceleration into t1. Okay, I don't know what is the time taken in the first interval. So the time t1 equal to v divided by a1, and in the first time interval I can write v square equal to 0 square plus 2a1 s1. So s1 equal to v square divided by 2a1. Obviously here it is the v is the maximum velocity here. Now for the second time interval I can say that is the 0 equal to V minus of A2 T2 retardation. Okay, after the first part, in the second part the train is retarded itself. So in the second part, the time T2, we can represent this in terms of this, that is V by A2. So here also we can write down 0 square equal to V square minus of 2A into S2. Here I am writing down S2. Basically it is that basically representing distance here. Basically from here we can write down that S2 equal to V square divided by 2A. So just try to remind this thing. This type is similar to that of the proof that we have discussed in the previous lectures. Here I am just taking the values here. So if I write down T1 plus T2, so T1 plus T2 is V by A1 plus V by A2. So if I take this common, then it will be 1 by A1 plus 1 by A2. The total time taken by it is, I have given, that is 4 minutes. So if I replace this thing, I can say it is 4 equal to 1 by A1 plus 1 by A2. No, this is not the end, it is V. Here is a V. So if I just take the total distance, if I take S, then S equal to S1 plus S2. S1 plus S2 equal to V square divided by 2A1 plus V square divided by 2A2. Okay, and this S1 plus S2, this distance is basically distance between two stations is 2 kilometer. So if I say it is 2, so it will be V square by 2, I can take common, it will be 1 by A1 plus 1 by A2. So this is the thing. So just think about, if I just square this equation, it will be 16. It will be 1 by A1 plus 1 by A2 whole square, and it will be V square. That I have done for the proving this thing. So if I just take the ratio of these two equations, how it will become, just see, it is 16 divided by 2 equal to V square 1 by A1 plus 1 by A2 whole square. Here is V square by 2, so it will be 1 by A1 plus 1 by A2. Okay, so it is 16 by 2, so it will be 8 and it will be 4. This V square cancels out, this thing will cancels out with this thing, and this 2 will goes off, so it will be 1 by A1 plus 1 by A2, and from here 1 by A1 plus 1 by A2 equal to 4. Sorry, it is 8 here, so 2 by 8, it is 4 here. So sometimes giving some values also the proofs can come. So the procedures that I am discussing till now, it is not different. So that I am going to tell you again and again. If you know the basic, if you know the equations, how to deal with it, you can prove different problems. You can face different problems. You have the potential to face different problems, and you have the confidence to face it and to answer it correctly.